A warm welcome to the Evolution Show. I'm Johan Landgren. I hope you're great. Today I continue my conversation with Joakim Byström, the CEO and founder of Absolicon, a world leader in solar thermal heaters that truly can change the game in the way we generate energy from the sun. Did you know that half of all the energy we use globally is heat? And we can generate this heat from super efficient solar collectors to run even large cities all year round by simply storing it as hot water underground. And this is already happening at large scale in Denmark, and soon in Helsinki in Finland as well, which means it should be applicable in most parts of the world. Join the conversation and tell me what you think in the comments below. And if you liked it, give it a thumbs up and consider subscribing to support the show. Next, I'm joined by the CEO and founder of Heart Aerospace, developing the world's first 30-seat hybrid electric plane. You definitely don't want to miss that. Okay, let's get going. This is the Evolution Show. Welcome back to the Evolution Show, Joakim Byström.
Tackar.
You are the CEO and founder of Absolicon, and yes, and in the previous episode I encourage people to check that out. We talk about how these solar thermal heaters work. They are fantastic. They are among, if not the most high efficiency rate of any solar heater in the world. And you're providing the production lines and the technology, and it's really exciting technology. So people, please check out part 1 to get into that. But today we're going to look a little bit more broadly about how these technologies and other solar technologies can be used. So how we can replace solar fossil fuels simply. So let's start with what we also mentioned in part 1, that half of our energy use is heat. I think that's very essential to start with.
Yes. And I can tell you who follow this show now to the end, you will have learned things that no one else knows when it comes to energy supply. So first, what Johan is referring to is out of the energy consumption in the world, only 20% is electricity, 30% is transport, and 50% is heat. But people think that the world is run on electricity because they are charging their iPhone and they are putting on the light. But in reality, all the goods that they are consumed, that is produced by heat. For example, a pair of jeans, to produce 1 kilo of jeans cloth, you burn 2 kilos of coal, because making cloth is a heat process where the cloth need to be heat treated and washed and dyed and washed and dried. And you don't see that when you go into a shop. You see the lights in the roof, but you don't think of all the coal that was burned to make the textiles that you buy. Actually, 8% of the global CO2 emissions is heating hot baths to dye and treat cloth. So and that's why we have this small logotype here, the heat is half logotype, to explain for people that out of the final energy consumption, half is burning fossil fuel to get heat.
Yeah, and so you can say that the low-hanging fruit when it comes to renewables in the solar sector is focusing on solar heat. People mix up this and think that they look at photovoltaics and see a few percent there, and I mean it's no way you can replace fossil fuels with that. And in partly you are right, but when you look at heat, it's a whole other game. Both in, as you say, production, generation of heat, but also in the way we can store it, right?
Yes. Electricity is very difficult to store. You can have an expensive battery and store it for a few hours or a day. But solar thermal, you can fill a big hole in the ground, like 50 or 100 or 200,000 cubic meters, and filling it up with 95-degree hot water in the summer. And you can have that to heat your city or your industry the whole year, because that large volume of water, it keeps hot over the seasons.
Yeah, and one way to use this is with district heating, and we mentioned that in the previous episode, but I would like to come back a little bit to that because it's so interesting to see what they have done in Denmark. For people,
Yeah, in Europe we have 6,000 cities running district heating. And the district heating is basically a big boiler over here burning fossil fuel or wood chip. And then there are hot pressurized pipes going into ground and heating the houses and the commercial buildings. In Sweden, every second home is heated with district heating. And this district heating system is fantastic because you got rid of all the burning in individual houses, and instead you have one large efficient boiler that is producing the heat. And what we say in the first step is stop burning in summer. There is no reason for this big boiler to run in summer when the sun is shining. You can have a solar thermal field and feed the hot water from the solar collectors out to all the houses instead. And then in winter, you can have this seasonal storage and keep the hot water from summer and operate the city the whole year. And in Denmark, there are a number of cities doing this, and actually 126 cities running solar thermal.
Yeah. So seasonal storage is definitely coming, and combining it with solar heat is definitely something we can scale up on a global scale, right?
Yes, and quickly.
Yeah, and quickly, yes.
Much quicker than batteries.
Yeah. So then to a little bit look at from the economic side. You have done this. You have said that you have looked into this, that how we can combine renewable energy in order to replace on a cost-to-cost basis. So can you take us through this?
Yes. When we discuss with those multinational food and beverage companies, there's a very strong idea that they want to change from fossil fuel to something else that is zero CO2 and cheaper than the fossil fuels. The problem is that there is nothing that fulfills this to 100%. But what we'll be able to show is that they can switch to, for example, renewable electricity, but that will be a quite high cost. Or they can switch to solar thermal. But if we would run the storage to run an industry the whole year around, the solar thermal will also be quite expensive. Or they can buy biofuel and burn that, but that is also very expensive. So picking any one of those three energy sources, that will be expensive. But what we can also show is that sometimes the electricity is really cheap. And sometimes if you use solar thermal in summer, solar thermal is also really cheap. So by combining renewable electricity when the electricity is low cost, solar thermal in summer and with a reasonably big storage, so that when the sun is shining, you run your factory on solar thermal, and then a renewable fuel that you burn when you don't have anything else to access. You actually can cut the cost of renewable heat by half compared to use renewable electricity. So this is how strange it might sound, a new idea in the food and beverage industry, that you need to combine different energy sources to get the lowest cost of heat. And we are helping now a number of industries to do those calculations. What is the cheapest combination of renewable energy sources? Because there is no silver bullet that immediately solves their problem.
No. I would like to come back to our previous guest, Arthur Berman. He's a petroleum geologist, and his message is that we are in the next few years might have a decrease in production of oil in the world as well as natural gas, and this will have huge pressure on the global economy, and there will be very big challenge to say the least to adapt to a decreasing availability of energy. And the short-term alternatives, according to Arthur Berman, will not be there. We will have to adapt to this reality, and this might mean that we have to decrease our consumption. He says that we should invest in renewables, definitely, but we also have to be realistic about the energy reality. I would like to hear what you think about this, and I know that we mentioned in the previous episode that this technology you are providing, in only 3 months, you could provide a production line, I think you said. So yeah.
Yes, if we start this by reducing the energy consumption, I think when you look at the food and beverage industry, it's hard to think that people will use less food and beverage just because the oil is getting restricted, or that people in countries that is growing, like Nigeria or India, where people are getting more and more money, that they would not by refined food and beverage. So I think the food and beverage industry will continue to grow. The energy consumption in the food and beverage industry, it's already quite efficient. We find sometimes that you could make it more efficient, but basically you need this heat to pasteurize the milk and to clean the bottles and everything. So I think in the food and beverage industry, you actually need to go away from fossil fuel and find this heat somewhere else. So, but we also find in some other industries that this energy efficiency is far away. For example, we work in the tea industry, and to dry 1 ton of tea, you burn 5 tons of firewood. But here you can make the burning of firewood more efficient, and you can at least cut it by half if you combine firewood with solar thermal and reduce the energy consumption in this drying process. So there are savings also. But when it comes to the speed of the transition, we have seen now photovoltaic is, of course, a fantastic technology, replacing electricity from coal plants. So when you charge your iPhone, you're actually using green electricity. But it has taken us almost 20 years to build this industry, and PV today provide 1% of the world's electricity usage. So it's a long process until renewable electricity from wind and PV can replace all the fossil fuel that is used today. And then when it comes to heat, that's a total different sector that needs to find their own solutions. But I think what Johan was referring to is how quickly we can set up solar thermal fields compared to the PV industry. Because the PV industry, when you need to double the PV industry, there is a very expensive supply line from the mines doing the silicon and this very difficult refinery doing super clean silicon, and then all the other different processes until you get a PV panel. But our solar collectors, it's basically some steel and some glass. You get the parabolic shape so that the incoming sun is focused on this narrow pipe in the center, and suddenly you have 160-degree hot heat and steam that you both can use directly in your industry, or you can store it from summer to winter. So the material that we need to make the solar collectors, it has only 3 months energy payback time, while a PV panel or a windmill, it has 2 to 4 years energy payback time. So we need very little raw material to produce an enormous amount of heat when we do the heat conversion directly. And that is partly because we have 76.4% efficiency compared to PV that might have 18, 20.
But let's say you live in the US, they don't have, as I understand it, that kind of district heating systems we have. They burn natural gas, basically, mostly. And so how could they make use of, either it's, you know, we're talking about your kind of technology with solar heaters or some other alternatives to replace this?
One big district heating used in the US are all the university campuses. So basically they all have a big fossil fuel boiler in one end of the campus and then pressurized hot water going to all the buildings on the campuses. So that's a specific niche market that we are looking at that could stop burning summer and run on solar thermal instead. Then when it comes to single houses, then there are other solar thermal technologies that can produce all the hot water that is needed for a house during a year in combination with renewable electricity.
Yeah.
So I think solar thermal, both for small houses, industries and cities, is an important part of this transition. And it is much more energy efficient than what it would be to use just electricity. But our technology, that is for industries and district heating.
Yeah, and people, they hear this like, yeah, but sure, but how about in a big city? But you're looking at this, for example, have done projects or feasibility studies in Helsinki. And you can please explain, I mean, we're not talking about, I mean, if you for seasonal storage, the space required is not that big that people might think.
No, that is true. The city of Helsinki, they have a district heating network serving the approximately 1 million inhabitants of Helsinki. And to get the heat for this district heating, they burn 500,000 tons of coal every year. And they have committed to have zero CO2 by 2030. So they made a competition to ask people, how can we replace those 500,000 tons of coal? And our proposal was to build 20 million square meters of solar thermal systems combined with those large seasonal storages. And we could actually show that this city system would be cheaper than to continue to burn coal for the city. And what we found that was very interesting also, that this large area of solar collectors around Helsinki, it was identical to the area of golf courses that existed around Helsinki. And of course, we don't want to build on the golf courses, but if it was possible to find areas for the golf courses, it should also be possible to find area for the system that can replace the fossil fuel for Helsinki. So even if there are some areas needed, it's no problem fitting it into the existing environment.
Yeah, and in this particular project, you were looking at replacing about 50% of the overall heat use, right? In the city of Helsinki.
In Helsinki, we aimed at 100%.
100%, wow. Okay, because that's
that
good.
Was then in combination with some heat pumps and some electric boilers and some other systems. So the whole system was 100%.
Yeah, and my point is that mentioning this project is very interesting because Helsinki, obviously, it's in a climate like in Sweden. They have a long winters. So if it could be applicable to this environment, it should be applicable to many cities, like in the central US, in northern, I mean, in Canada, definitely. And you name it.
Definitely. And you can see on the background here I have. This is an installation in Sweden where we produce 110-degree hot water for the local district heating network. So it's no problem making high temperatures even in cold climate.
Yeah. And then people may wonder, oh, this sounds fantastic, but why don't we see this now? Why is it only happening at a large scale in Denmark, for example? And you have a project going on in different parts of the world, but why are nothing happening? Can you say something about that?
Well, I think that we are seeing this. We just need to look at the right places. And I think it's quite incredible that in Denmark, 126 cities build solar thermal systems without anyone noticing. And I think it's the same with the solar thermal systems that we have built now with Carlsberg and Peroni and Colgate, that they are out there. You can look at them, you can visit them. But the knowledge about that it's possible to run your city or your industry on solar thermal, it's still very low. And people are mixing up solar thermal collectors that makes heat with PV panels that makes electricity. So we have a long way to go before people actually understand the enormous potential of harvesting the sunlight immediately and making heat with 70+% efficiency. This is something that people don't think about.
No. Another technology I thought could be interesting to combine, basically another way to store your solar heat that you generate could be with hydrogen. I had another guest, the inventor Hans-Olof Nilsson, and he has built a 500 square meter 100% off-grid house. And it runs on solar PV, but also solar heat, solar thermal. And he generates his own hydrogen, which he then has for seasonal storage, so basically to run the house when there is not enough direct sunlight or direct solar heat. And it runs this huge house. It's totally off-grid. And so couldn't it be interesting to, aside from, storing heat in water pools or containers, like you mentioned, underground, with also hydrogen?
I'm not sure how diplomatic I should be here, but hydrogen is prohibiting expensive in most applications. If we look at those food and beverage industries, for example, it would be 5 to 10 times more expensive to run hydrogen than to run the natural gas that they are burning today. So there's no way that this kind of light industry can switch to hydrogen. The industry that will switch to hydrogen is the steel manufacturers, because they have to replace the coal and it's nothing to replace it with but hydrogen. But when it comes to single houses or to light industry, there are many ways that is cheaper than running hydrogen. This said, it might be so that in this combination for a small brewery, that where you combine renewable electricity, solar thermal, and the renewable fuel, that this expensive renewable fuel could be hydrogen that runs for maybe 1,000 hours per year, but it runs when the electricity is super expensive to buy from the grid. So there is a niche for hydrogen there. But what we have run into with the food and beverage industry, that they thought, oh, hydrogen, we can run our industry on hydrogen and we just can pick one energy source and that would be fantastic for us. But sorry, no, there is no such silver bullet that can allow you to reduce your energy cost and get zero CO2. You need to have a combination of different energy sources.
Yeah, and I think that's what we see also with Hans-Olof Nilsson's house. I mean, he's combining batteries, he has solar heat, he has solar PV and so on. And he also mentions that the biggest cost right now for hydrogen, aside from the different parts, but they're not so expensive. What's expensive is the containers for to store the hydrogen. They are made now in very small ones, specialized ones, and so on. And he is talking about decreasing the cost by 75% or more when you make bigger scale hydrogen or adapting these, so on. But to the specific customer you're looking at. But I agree that I think that it's as it looks right now, it is definitely something more of a niche product.
But also, you know, if you have electricity and you turn that to hydrogen and you turn it to electricity again, you have like 50% losses.
Yes, conversion losses, yes.
But if you look at those pit storages where you put in 95-degree hot water and you take out 95-degree hot water, we have 5% losses from summer to winter.
Yes.
So when you want heat, those kind of large storages and solar thermal, that's the way to go. And then to combine it with renewable heat and renewable fuel.
Yes, I agree, and I think that's a good point you make that, because we have to make the distinction between making heat and making electricity. For making electricity, hydrogen could be very good, because if you have a surplus of electricity power from generation from the summer, for example, and you want to have an off-grid solution or microgrid, you might use that surplus power to make hydrogen. But if you want to store heat, which is half your energy use at the minimum, in a house I think it's 75% or something, then you want to have direct conversion or storing it in water, as you said, right?
And maybe this can come to a news to some people also, that this surplus of electricity that we get nowadays, when we build those large heat storages, there will be no surplus of electricity. All the surplus, when the electricity price goes down below a certain level, we will start a huge electric boiler and we will put this hot water into the heat storage. So this hydrogen dream that the electricity is cheap and it doesn't cost anything, that's just a function of the market not working at the moment. But this surplus electricity, we can eat every kilowatt hour of it. So don't base the hydrogen budget on zero cost electricity, because there will be no zero cost electricity.
No, that's totally agree with that. Yeah, and okay, but the follow-up question that I have is your production lines. If we were to imagine that you could scale them up, I mean, imagine you are scaling them up, you're working on that, but let's say that we built enough to meet the world demand, you know, really scaling up your production lines. Have you looked at any specific industry? You have mentioned breweries and so on, but where should we start and focus on first?
We think the food and brewery industry, food and beverage industry, is the low-hanging fruit, because they have such a pressure from their customers and they have made this kind of strong commitments to get zero CO2. But it's the same with the textile industry, with the chemical industry, with actually the petrochemical industry. You know, the oil that you burn in your car, 1/3 was burnt in the process of making the petrol. And also this heat you can produce by solar thermal. The mining industry is consuming enormous amount of heat when they are preparing the minerals. And also, if you look at the pharmaceutical industry is using a lot of heat. So basically all the light industry can convert to a solar thermal. What we cannot do is the cement industry and the steel industry, but they have their own problems. So there are a market for at least 500 robotized production lines around the world just on this light industry, as been reported by IRENA and IEA. And we think that this is the solution, to have a locally run and locally owned production line using local raw material to mass produce parabolic troughs that produce the heat and steam that is needed for the local industry. That's the way to actually solve the climate challenge.
And that's also a good follow-up question I would like to relate to. I mean, you have, if you look at how many, we're talking about the industry, but let's say you used, you made 100 Absolicon production lines in the world, and you wanted to focus those on also housing or residential areas or, district heating. Can you say anything, how many households would that, how many people could that provide energy for? Do you have any idea?
Well, we made a plan for Europe where we showed that we could easily replace 1/3 of all the district heating in Europe with solar thermal. So if you look at the big cities like Paris and Berlin, they are all running district heating. So we are talking about tens of millions of people in each country here that is heated by those 6,000 district heating networks. And there is quite a strong drive now in Spain that smaller communities are establishing new district heating networks. And then the idea is all the time to burn wood chip in winter and to use solar thermal in summer. So those new district heating networks we see in Southern Europe, they always have solar thermal as one of their components.
And they could add seasonal storage by using water in underground deposits as well. Yeah. That would be the ideal solution, I think.
Yes, and then combination with a biofuel boiler.
Yeah. Yeah. And but let's say you were in charge of this, Manhattan project in the world, and you had to make really tough decisions, and you only had 10 years to replace coal, oil, and natural gas. Where would you start? You have hinted on it, but it's just interesting to hear your perspective on this.
Yeah, I think people in general does not understand what a gigantic challenge it is to change this dependency on fossil fuel. And my area of expertise is this heat need in industry. And I think the tools that the European Commission have put now in Fit for 55, there are good tools there. They will help the industry to transition. The problem is that the industry hasn't started yet with the heat, and that will make it go much slower than what is intended. Because the way I think you should do it, even in a Manhattan project, is to step by step put up more and more cost of fossil fuel, and at the same put research money and subsidies on renewable heat. And that would make it possible for the industries to do this transition. And we see these are in the Fit for 55 package. It's too slow. So you need to have even stronger commitment from the European Commission, and you need the individuals, the people in those industries to start taking action. And there's a huge challenge here is in educating the factory owners and the workers in the factories how to run a factory that does not just have one big steam boiler in the back of the factory, but actually have 3 or 4 different energy sources to reduce their CO2 emissions. And that's a big change in the mentality in the industry. Yeah.
And I think I would maybe add to that in the countries like India, growing very strongly right now, being a new producer in the world, sort of coming, to maybe replace China because of the, the costs of production. You know, you have a growing middle class in China, so they're demanding higher pay, and you know, production is moving into China, India, and so on, but also into other areas in Southeast Asia, I would say. So that could maybe be an area, you know, region to start with as well. As you said, they have a growing energy need, and for them to just jump, you know, to decrease energy use will be very difficult.
Mm. What has happened now also in this Fit for 55 package is those carbon import taxes that actually is changing the whole way that people are looking at manufacturing. If you're going to export aluminum from India to Europe, you will need to pay the European CO2 taxes. And if those taxes can come into textile and food and beverage as well, we would very efficiently from Europe help the rest of the world also to make this transition. Because in India now, there is no strong tool to make the industries reduce their CO2 emissions. It's still burning coal and to have the lowest cost in the textile industry, for example. While in Europe it looks differently. But with those import taxes, then we can export the European CO2 policies to other countries.
Yeah, really interesting, and I hope to have you back and I wish you all the best with the production lines. I think it's very promising and really important work you're doing at Absolicon. Yeah, I hope we can have this conversation in the future and see what's have happened so far at that time. And so thank you again, Joachim.
And I promised in the beginning that the people who listened in would have learned something that very few other people know. And I think that the two things I want you to bring is, first this, that heat is half of the final energy consumption. Very few people know this. And the second is that the energy transition in industry is not switching from one fuel to another, but to combine different energy sources, renewable electricity, solar thermal, renewable fuel, to make zero CO2 emission from a brewery or a textile plant.
Good point. Thank you. Thank you again, Joachim.
You're welcome. Thank you.
That was all for today, folks. I hope you liked it. And if you did, don't forget, give it a thumbs up and consider subscribing to support the show. Next, I'm joined by Anders Forslund, CEO and founder of Heart Aerospace, developing the world's first 30-seat hybrid electric plane. The plane Heart ES30 is to start test flights in 2026 and be commercially ready by 2028, with real orders from United Airlines and several others. You definitely don't want to miss that. I hope to see you next time.